I'm going to go ahead and record these. Before you can graph A, what do you have to do? Yeah, subtract your 2x from both sides. All right, and we get what? What do we bring down for this one?
3y is greater than negative 2x plus 5.
Plus 5. Yes, bring them down separately. Okay, and then last thing you do?
Divide all the way by 3.
Yes, divide by.
Then you get negative 2 over 3x plus 5 over 3.
Mm-hmm. Okay, and then let's go ahead and graph that because this is one of those systems. Okay, we're graphing them both on the same graph. All right, so this has a fraction. All right, these really messed us up when we took this test. In order to graph it with a fraction, you need a list of values in your table. Okay, because you're not going to go to 5/3 on the y-axis. Okay, so first let's go x, y. Get your graphing calculator out. Give me 1 point that's on this line.
Negative 3, 7.
Always.
Negative 3, what?
7.
7. Okay.
Where did you get that?
Y equals.
Put in your y equals
Mine, I didn't get that.
negative
I
2.
got a positive 3, 3.
All right, so on this one, we only do a complete box when there's points on both sides. Okay. You only want to shade the spots that do not have an arrow extending out. So look at the bottom. Can you shade on the bottom of this graph? Yes, okay, because there is a point there. So I'm going to shade up until you hit that point. Okay. Can you shade on the top?
No.
No. If there is an arrow, do not touch that part of the graph because it's still going up and it's still going out. Now can you shade on the left side?
Yes. No, the right side.
No, there's an arrow. You can shade on the right side though. So because you don't have shading on both sides, that means they're not in between two numbers. When you have shading on both sides, you put the X in the middle and you have a number on both sides. This one you do not. It's almost like looking at it and saying, okay, for my domain, I'm starting here and I have an arrow. If there's white space, you're arrowing out, okay, like this. And then y'all know how to write an inequality when it's flat, right? Okay, so this is X is what to 3? X is less than 3, and if it's crossing at 3, it better get a line. Less than or equal to 3. Okay, at negative 2, your arrow needs to be going up this way because that's where the white space is, and you go down to this spot. Is this a solid dot or an open dot? It's solid. So that means your line, you're going to have a line under the inequality sign. This is a Y. And you're starting at what point? negative 2. Now, the numbers that we have kind of shaded right here, are they bigger than negative 2 or are they smaller?
Bigger.
They're bigger, like 0, 1, 2, 3, 4. All of those are bigger than negative 2, so it's greater than or equal to negative 2.
So they don't got a point. Like we don't fix the number.
So we're going to shade the bottom all the way up to
No.
here. And then what else can we
The
shade?
left side.
The left side.
That's it.
No, you can shade the right side a little bit too.
No, you can't.
Okay.
Cause it's going
Oh,
that
yeah,
arrow.
the
The arrow. Yeah, and this might help you. If the arrow, like, you can't tell, extend it, okay? Extend it to where you can see, okay, I cannot shade over there.
They don't have an arrow.
Yeah, you only shade all the way around when there's no arrows. Okay, so look at the domain first. Okay, when there's only shading on one side, the letter goes in the front, okay? So what number are you starting with?
Equal to
Negative 4, okay? If you put like an actual inequality like graph, like a flat one on here, it would be going to the what side? The right. So that means it's what? Greater than or equal to negative 4, because there is a point there. Now this is the one that messes people up all the time. This range right here. Okay, look at your y-axis. What's the smallest number on the y-axis that you hit?
Zero.
Is 0, right? You go all the way up here. That number is not there, and it might help you if you actually put 0 at the origin for you to like see that. So, and it's all these numbers above it. So it's 0. Y is what to 0? Greater than. And is it a solid dot or an open dot? Look back at over here. It's a solid dot. So it's a line.
Alright, I don't think we're gonna finish. Oh yeah, we will. Wait.
Yeah, we are.
Negative 2, 5 is your first point. 0, 3. 1, 2.5. And 2, 2. So for negative 2, 5, we go to the left 2 and up 1, 2, 3, 4, 5. Then we have 0, 3 on the y-axis.
You know before we can.
1, 2.5 is about right there. And then 2, 2 is right here.
That's 2, 3.
2. Oh, I'm sorry. Yeah, thank you. 2, 2.
I think it's exponential.
Okay, what do y'all think? Y'all agree? Exponential, because it's getting, you got that decimal in there too. That kind of tips you off, and it's getting really close to maybe 2 possibly. It might go down actually here. You don't have to know exact. Okay, all you have to know is that it looks like an exponential.
Yeah.
This is negative 2, 4. Write your points down. Negative 2, 4. Then we have a negative 1, 2. Then a 1, negative 2. Then positive 2, negative 4. All right, what do we think about this one?
Linear.
Okay, this is definitely linear. Okay, so I would connect these. Linear means it is a function and it is a line. All right, negative 1, 1. Negative 1, 1 is left one end, up one. Then we have 0, 0. Next is 1, 1. Immediately, you should probably see what this is supposed to be. What do we think without even grabbing the next point? It should be a quadratic. Anytime it like goes down and then back up, it's going to be a quadratic. And 2, 4 kind of further lets us know. Quadratic. Right. First thing we need to do is write down all our numbers. Negative 1, negative 5, 0, negative 3, 1, negative 1, 2, 1, and 3, 3. So go ahead, let's plot these. Negative 1, negative 5. Then we have 0, negative 3. We have a 1, negative 1. Okay, so we're doing 1, negative 1. 2, positive 1. And then 3, 3. I feel like that was, yeah. Okay, here we go. What does this look like to y'all?
Linear.
This is linear, okay? So, to get the regression model, okay, first, everybody, let's make sure our diagnostic is on. To turn on your diagnostic, go to second, and then hit 0, and then scroll down to diagnostic. Everybody check this right now. Diagnostic on, and then click enter. Go to stat, calc. No, not calc, hold on. First you have to go to stat, edit. Go to stat, edit, and I want you to put in these two lists of numbers. After you get your list, this is a linear regression. So you go to stat, calc, and which one is linear? What number? It's 4. So stat calc 4. And then click enter. I think it's like 3 or 4 times. Maybe 5. It's a lot. Once you do that, you should get an A, a B, and then an R. Remember, the R is your correlation coefficient. So, yes, it's y equals 2x minus 3. If R is 1, is that a strong correlation? Yes, and it's a strong what? Positive. It's actually perfect, okay? Because all of these, the points are not kind of like here and there. It's like they're exactly a straight line, okay? Negative 1, and then 2.2 is kind of like right here. Then you got a 0, 0. Then we have 1, 2.2, somewhere up there. You have a 2, 8.8. Somewhere, it's really close to 9, okay? And then you also have a negative 2, 8.8. You always want to graph these first because it might not be linear every time. Okay, because right here, does this look like a line? No, it looks like a quadratic or a parabola. So when you go to your calculator this time, you hit Stat, Edit again, and then put in your two lists into your calculator. But instead of hitting Stat, Calc, 4, you're going to hit a different number. Okay? Go ahead and get those into your tables, and then we'll look at it together. Use a 5 this time. Enter, enter, enter. Okay? And then I want you to give me those numbers. I think you should get an A, a B,
2.2.
C.
And
The
then
other
you get the B
zeros.
is like 0.
0. And then the C is also
0.
0. Okay? So in it, even your calculator's nice about it, and they tell you you're supposed to be using ax squared plus bx plus what? C. So all you have to do is put these numbers where they belong. So we would put 2.2 what? X squared. And if this is 0x plus 0, what does that actually look like?
You don't put that.
Just 2.2x squared.
Yeah, you don't use these right here, okay? Those are just going to be invisible. And I shouldn't put an X there, that's kind of confusing. They become zeros. So y is equal to 2.2x squared. Does it give you your r on that also? Yes, what is your r? 1, which means it's perfect. It's very strong, okay?